In this video, I'm going to talk about logarithmic functions. Logarithmic functions are also called logarithms, or simply logs. Many people are scared of log functions, but they're actually very simple. Here is the key. Log functions are the inverse functions of the exponential functions. If you want to recall what inverse functions are, please click at the link at the top right corner. An exponential function is written as a to the power x, where a is the base and x is the input of the function. The inverse function of exponential function is the logarithmic function, as we just mentioned, and we write it as log base a of x, where a is the base and x is also the input. Because exponential and logarithmic functions are inverses, they will undo each other. By that, we mean if we do f and then f inverse acting on x, we will simply get x. Because f inverse of x is now the input to f, we have a to the power f inverse of x is equal to x. F inverse of x is log x base a. Substituting this back into this equation, we have the first identity, a to the power log base a of x will be equal to x. The undo property of inverse function also works backwards. By that, I mean f inverse acting on f of x will give us x. Since f inverse is the log function, by plugging in f of x into the function, we get log of fx base a is equal to x. Substituting a to the x back into f of x, we get the second identity, log base a of a to the power x will be equal to x. These two identities are very useful. For example, if we want to find the value log base 16 over 81 of 27 over 8, then what we can do is to set this as an unknown y. To solve for y, we can apply the exponential function base 16 over 81 to both sides of the equation. So we get 16 over 81 raised to the power log base 16 over 81 of 27 over 8, and that is equal to 16 over 81 to the power y. Exponential base 16 over 81 and logarithmic base 16 over 81 will cancel out each other as mentioned in the last slide. So we will get 27 over 8 is equal to 16 over 81 to the power y. From here, we can solve it like a normal exponential equation, meaning that we want to transform both sides of the equation into the same base. 27 over 8 can be rewritten as 3 over 2 cubed, while 16 over 81 can be rewritten as 2 over 3 raised to the power 4. The exponent y outside is still there, so we should keep it. And we can see that these two are almost the same base, except that 2/3 is the reciprocal of 3 over 2. So we can keep the left-hand side and rewrite the right-hand side as 3 over 2 to the power -4, and then raised to the power y. In this way, both sides have the same base, and we can just compare the exponents, and we will get 3 must be equal to -4 times y, and y will then be equal to -3 over 4. In this way, we finish computing the output value of this exponential function by using the fact that exponential functions and logarithmic functions are inverses of each other. Other than these two identities, There are still quite a number of identities that we should remember for logarithmic functions. The first one is the log of 1 for any base is always equal to 0. This is because 1 can be rewritten as a to the power 0, and hence if we apply log base a to 1, then this is just the same as log base a of a to the power 0, and according to this identity, we get 0. The next 4 identities have a correspondence to the 4 operations in arithmetic. The first one is log of x base a plus log of y base a will be equals to one single log, but the input is x times y. After addition, then of course the next one is subtraction. So we have log of x base a minus log of y base a is equal to log base a of one input, which is given by x over y. The third one is multiplication, but this time we only have one single log on the left-hand side. So we have x times log base a of y is equal to log base a of the number y to the power x. The last one has a very special name called change base formula. And this one involves division. We will have log base a of x divided by log base a of y, and that is equal to one single log, but the base is no longer a, but y. So we have log base y of x. This formula is a little bit weird, but I remember it in the following way. Y was in the basement of this fraction, and hence it becomes the new base in the log function. Another quick comment is that many people mix up these two expressions. Please recognize that this is one number, x over y, input into one log function, while this is a fraction between two numbers, log x base a and log y base a. In the rest of this video, we are going to use these identities to rewrite this fraction so that the new expression involves only one logarithmic function. In the numerator, we kind of realize that the second bullet point will be useful. However, we can't use it directly because this identity must have coefficient 1 for both logarithmic functions, while here we don't. We have 3 and 2. What we can do is to first use the third bullet point, meaning that if you have a coefficient in front of the log function, we can move this coefficient up as a power. Using this identity on these 3 terms, we get log base 7 of 5 to the power 3 minus log base 7 of 3 to the power 2 divided by log base 7 of 2 to the power 2 plus this term 2. Now, the numerator can be simplified by using the second identity, and so we get one single log in the numerator with 5 to the power 3 divided by 3 to the power 2 as the input. As for the denominator, we cannot just directly add the 2 to this term, so we have to do some trick. And we realize that 2 can be thought of as log base 7 of 7 to the power 2 using this identity, and hence we are going to rewrite this as log base 7 of 2 to the power 2 plus log base 7 of 7 to the power 2. Now, we can apply the first bullet point to simplify the denominator into one single log, and we will get log base 7 of 2 squared times 7 squared in the denominator and we will keep log base 7 of 5 cubed over 3 squared in the numerator. At this stage, we are very close to the final answer, but we still have a fraction involving a log divided by a log, and it is time to use the change base formula. According to the change base formula, we will get one single log with the new base 2 squared times 7 squared, and the input is 5 cubed over 3 squared. Of course, we can multiply these numbers out and we will get log of base 196, and the fraction is 125 divided by 9. And that is the final answer. Thank you very much for watching this video. If you like it, please subscribe to our channel and we will learn more fun math together. Thank you.